Hi, I'm Mr. A. Are you confused about distributing radicals? Then you're in the right place. Let's get started. So in a previous video, we multiplied and simplified radicals, which we're going to use today to help us distribute with radicals. Let's jump in. If we look at the square root of 5 times the quantity, the square root of 3, plus the square root of 7, we're going to distribute like we always would have with numbers or variables. Now we're just going to do the same procedure with radicals. The square root of 5 times the square root of 3 would give us the square root of 15. The square root of 5 times the square root of 7 would give us plus the square root of 35. As we look at these two numbers, we know we can't break these radicals down, so this will be our final answer. Let's look at the next example. The square root of 2 times the square root of 2 minus the square root of 6. So we're going to go ahead and follow that exact same procedure. The square root of 2 times the square root of 2 will give us the square root of 4. The square root of 2 times the square root of 6 would be minus the square root of 12. Now the difference between the first example and the second example is going to be that we can break these two radicals down. The square root of 4 is going to simplify to 2. The square root of 12 would be minus 2 square roots of 3. Let's give you one to try on your own. You can pause the video when you're ready and then check the answer afterwards. So for the try, go ahead and distribute the square root of 3 into the quantity, the square root of 15 minus plus the square root of 11. Pause the video now, and when you're ready to check, go ahead and press play. Okay, folks, so after you have done this, you should have arrived at the answer, 3 square roots of 5 plus the square root of 33. Let's move on. Okay, for the next example, let's look at something a little more complicated. Let's look at the negative 4 square roots of 2 times 2 plus 3 square roots of 10, this quantity here. So what we're going to go ahead and do, same procedure, we're going to distribute the entire negative 4 square roots of 2 into the first term. So again, you know from previous videos, we can only multiply the outside numbers with outside numbers. So negative 4 times 2, of course, is negative 8, and the square root of 2. And then we're going to do the same procedure over here when we distribute. So we know that the negative 4 times 3 would give us negative 12. And the square root of 2 is underneath, as is the square root of 10. So that would give us the square root of 20. And as always, we are going to have a sharp eye out for this. We're going to make sure that we can reduce anything that can be reduced. So the negative 8 square root of 2 stays negative 8 square roots of 2. This over here will reduce to negative 24 square roots of 5. And for our last example, let's move into 8 square roots of 3 times the quantity 5 square roots of 5 plus 4 square roots of 6. So we're going to go ahead and we're going to keep all the things that we've been talking about in mind as we distribute. So the two outside numbers here would be 40 and the square root of 15. The two outside numbers here would give us 32, so plus 32, and the square root of 18. Again, we're going to go ahead and see what we can simplify. So the 40 square roots of 15 won't be able to be simplified because we can't break down 15 into anything meaningful for us. However, we can break down the 18. And as you know, once we break that down, that will end up giving us 96 square roots of 2. So to end the video, why don't we do a try to see if you can do one of these on your own. And for the try, let's go ahead and do 2 square roots of 6 times the quantity 3 square roots of 10 minus 5 square roots of 3. Go ahead and pause the video to try this example, and when you're ready, press play to see the answer. Okay, let's check out the answer to this. So this would end up being 12 square roots of 15 minus 30 square roots of 2. So, if you were confused about distributing radicals, I hope you found yourself in the right place.